My research is focused on the role of terrestrial ecosystems in Earth's climate system, and one limiting factor in how much carbon terrestrial ecosystems can store in the form of plants and soils is how much water is available to the ecosystem. So I came out to Santa Cruz Island to understand the role of clouds and fog in the growth and metabolism of the bishop pine forests. The bishop pine stands on Santa Cruz Island are very unique. They are among the southernmost populations of bishop pines in California, and they are believed to be existing on Santa Cruz Island because of this unique microclimate provided by clouds. So there's this belief that they are a very sensitive population to changes in climate, such as changes in temperature, precipitation, and also changes in either cloud occurrence or cloud height. So climate change and global warming are very important to the survival of the bishop pine stand because they rely heavily on the shading and water inputs provided by clouds. And clouds are among the most largest uncertainties we have in climate change. So as the Earth warms, we really don't know how clouds are going to change. And so we need more research to understand how clouds might change and how that may affect the distribution of ecosystems over land. For our research, what we did is we set up 2 research sites that varied in the amount of cloud cover that they receive in the summer months. So this is marine stratus clouds that are formed over large extensive areas, and what happens is the prevailing winds blow the clouds up over the island. So the furthest west on the island tends to get the most amount of clouds, whereas as you move further east into the island, you have decreasing cloud cover. And so what we did was we set up 2 sites, one that gets more clouds and one that gets less cloud cover, and we contrasted these 2 sites to see how they differed in their bishop pine growth, but also overall ecosystem carbon cycling processes. So this is what we call a fog collector. And what it does is it allows us to measure how the fog is contributing to the water balance of the ecosystem. So as the fog comes through, the cloud water droplets are intersected by these strings, and they accumulate and then drip down to these funnels. And then we have all the water from the fog going down into a rain gauge tipping bucket, which then actually allows us to quantify how much fog drip is occurring at the site. So one of the main results from our research was that clouds provide 2 things that influence the growth and metabolism of the bishop pine forests. Clouds provide shading in the summer months, which decreases temperatures and also decreases evapotranspirational losses of water from the ecosystem. But they also provide water inputs, and they do this through the form of fog drip. So as the clouds push through, they intersect on the bishop pine needles, and cloud water droplets accumulate and then eventually drip to the ground. And so this is an additional water input that we found that was particularly important for the soil microorganisms and how they function in the summer months.